Well, might as well get started. So I'm going to start a timer here so I don't go over. A bad habit. My name is Marc Zeedar. I'm the publisher and editor of xDev magazine. And we've been publishing for 16 years. So long time. I've been using Real Basic since August 98, I think, is when I started it. So long time. Doesn't mean I know anything, but so today I'm going to talk about object-oriented programming. Let me get a little poll about how experienced you are at object-oriented programming. Are you guys really familiar with it or a little bit familiar with it? Okay, got some few people are. So this is kind of going to be a little bit of a beginning session. I'm going to try to cover some of the basics of object-oriented programming just so you get kind of a good understanding. That's kind of my goal, is to get you a good feel of what object-oriented programming is all about. And my main goal is to provide you with some practical examples to really show you. I find I don't understand very well if somebody just talks vague, abstract things and says, oh yeah, you need to kind of do this. I like to see code and see stuff in real world showing me stuff actually working that way. So that's kind of my main goal. We've got a lot of demos and different things to show you, but these are all available however they're distributing the stuff for the conference. But I'll also have links at the end of the thing where you can just download it from my website if you want, and you'll have access to all the different code projects, and you can play with it. So I kind of look at OOP as a little bit like, exercise or drinking water or eating healthy food. In a way, you can't get enough of it, right? So you can always use more OOP. And so my goal is to get you excited and have you, try to refactor your projects and use more and more OOP, and benefit from all the benefits that you're going to get from using more OOP. So let me ask you a question. If you don't use a lot of OOP in your projects right now, or feel you don't use enough, why don't you use enough? Any answers to that? Understanding
of how all the pieces fit together.
Okay, that's a good one. Any other?
Extra work up front.
Extra work up front. That's a very definite.
I'm just so used to procedural programming.
That's a good one. Yeah. If you come from other programming backgrounds, especially if you're real old school, you don't. Yeah, exactly. Really old language. You just get used to doing stuff in a more sequential way, and you don't tend to do everything in an OOP fashion. So my goal is to help you, show you how OOP is going to make your code so much better that you'll get so excited you'll be like, I really want to do everything in an object-oriented way if I can. So let's talk a little bit about the basics of object-oriented programming. So first thing you need to remember is, objects, it's just a metaphor, okay? It's a lot of times when I first started hearing about objects years ago and looking at it, it felt a lot like, it's some kind of magic thing. It's some kind of, magic bullet. It's going to cure all these things and fix things, and it just sounds, exciting and awesome. And then it's like you get into it and it's just a metaphor. It does help with your understanding, and there are some aspects of it that make the understanding, clearer. But it's important to understand, you don't have to use objects. You can do it the old way. Not every project is suitable for OOP. That's a good one. If you have just a small, like I do a lot of small utility projects just for myself. Sometimes I don't make them object-oriented just because it's just a one-off project. It's 15 minutes to do some little task. I don't need it to be, majorly object-oriented. Object-oriented does take extra planning and time, as we mentioned, and doesn't solve every problem, and it creates some of its own problems. So we'll look at that as we get into this. So first thing we're going to look at is what we call a class. You're all probably somewhat familiar with this. I'll try to go fairly fast with this. If I go too fast, just let me know. But basically, a class is just, three different metaphors I'm using here. It's like a pattern or a definition. So it's like DNA, right? It's going to define how something is. It's if you had a die or mold, and you're going to manufacture something, it's the blueprints for like a house or building, right? So it's not the building itself. It's just the definition or the design, okay? So you have an object itself, the instance of a class. That is the actual object. So the DNA would be the class. The actual cat would be the object, right? So the house is the object, not the blueprints. So just to summarize that, the little chart here, just to remind you of that, because this is very important especially when I first started out. It was very confusing to me, the difference between these two. So one of the things that I like to do as just a little tip, I found a lot of times when I would see code like this first line. And I would end up very confused, and I couldn't figure out why. And then I realized they're using the term apple here as a class. But apple, if I say the word apple to you, you picture an apple in your head, right? It sounds like an object. And yet, the way it's written here, apple is a class. So it becomes kind of confusing because you're going, wait a second, it sounds like an object, but it's not. It's a class. So I like to name my classes with the word class in it, or the word type, something like that, so that it's more clear to me that it's not an actual object, it is the class, and then something else. Then I can use the word apple here as the actual object, because it is an object, it's not a class. So just a tip, you don't have to do it that way, but I find it makes it a lot easier. So objects can have properties, okay? The properties are the various characteristics of the actual object. And the neat thing about this is if you have multiple objects, they can have different characteristics. So they can have different colors, different sizes, shapes, colors, things like that. So when you look at all three of these aspects together, you can kind of see in this little chart here that I created, a little summary of exactly what the different things are. So you have the blueprint, you have the house, and then you have the carpet color in the house, right? That's a characteristic of the house. Objects can also have methods. So methods think of them as like verbs, right? It's an action. It's the object is going to do something. Probably the most common thing that we've probably seen in a lot of code is like a draw command, right? Where the object knows how to draw itself. And so the main, whatever's talking to the object doesn't have to know how that object would draw itself. It doesn't have to know anything about what the object is or anything. It just says, object, draw yourself, and then the object draws itself. And I'll show some code later, an example of objects. I'm having a drawing program that I'll show you, and basically each of the objects that you draw in the drawing program know how to save themselves to disk as XML. And that's using a method that lets them do that. So they can also have, so I should also mention on methods that methods can take parameters and they can return a value, okay? Whereas you also have can have events, and events cannot return a value. They can only, you can send something to them. And objects can also create events to call other events, right? So an object can receive an event. So your main program, for example, could take a mouse click and then pass that to the object and say, you were clicked on. And then the object can say, oh, I was clicked on, I'll do something. And but the object can also send events to other sub-objects and other things in its thing, in its class. Objects can also, so when you have, sorry about that, when you have objects, they can also override what their parent object does, which we'll get in a second because I'm going to talk about inheritance. I'm getting ahead of myself, sorry. So one of the major features of object-oriented programming, this is pretty much the key thing that helps you be able to save a lot of time in code, is to be able to take an object and create sub-objects from it. Okay, we call that subclassing. So you have an initial class, you can create a subclass. The subclass basically inherits everything the parent class had, except you can go in and change minor or major things about it. So you could change various things like the color, the shape, the size, what it does, how it operates. But the stuff that you don't change gets inherited from the parent. So in the example that we'll see in a little while, where I'll show you my drawing program, it works really cool because I can add a new, for example, one of the objects we'll add is a text tool for drawing text in the drawing program. Well, when we add that tool, we don't need to add all the code for like the X and Y position of where that text is located, the size and shape of the box, all that kind of stuff, because the parent object already does that. The only thing we have to add is the actual text value that the user is going to type in, for the text, because that's the only thing that's really different from the default object. The default object knows about its color, its size, its shape, things like that. So when we save that as XML, the default stuff all gets saved, and then the custom object says, oh, well, I also have a text field, I will save the text. And so this saves you a lot of time, because instead of each object having to save the same kinds of things over and over again, it only has to save the stuff that's different. which gives you a lot of power. I'll show you when we get a little bit closer to that, and you'll see it's pretty cool. So other thing that's really cool about inheritance is that if you went and changed something on the parent object, immediately all the sub-objects get that. So when you're writing your program and you've got all these objects in your code, and then all of a sudden you go, you know what, I want to add this feature, change something, you change the parent thing, and all your other objects get that benefit. They get that change, and that can save you a lot of time. So I'm going to show you an example of this, a quick little demo. See if it works on this screen here. So this is a very crude, I don't hesitate to even call it a game, because it's not really functional as a game. But I will run this, and basically it's sort of a Space Invaders type thing, but it doesn't actually do anything. There's no explosions or anything, sorry about that. But I'll create some more enemy ships here. So the main thing I want to show you here is just, I don't even have collision detecting, so the little human ship nothing happens. But the main thing I want to show you here is let me add a few more ships. Each of the different colored ships have a different characteristic. They move a different way. So you can see like the yellow ones just go straight down. The green ones, they don't really move very much. They're kind of slow. The red ones are obviously the hyper ones. And sometimes there's some blue ones. I can add some new ones. There's a blue one. Blue ones are kind of in between. And the way we get these characteristics is if you actually look at our code here, what I've done is I've created a class called enemy class, and then I've created subclasses of enemy class. So if we actually look at our inspector, we can see that enemy class is a subset, it's a subclass of ship class, and then enemy red class is a subset of enemy class. So all the enemy classes, you know, all the enemy ships have an enemy class as the parent, so they all inherit whatever characteristics that they have. They don't actually have anything because I don't have any code there. But if we look at how they actually move, this one here's the red one, and it's fairly simple code. It's just moving left or right, you know, randomly. But the range of the movement down and left and right is broader than, say, for example, the blue class is only moving 10 both directions. And so this gives you a way. And then that yellow one that was really, you know, just goes straight down kind of thing, it doesn't even go left or right, it just goes straight down. And it just moves a random number between 5 and 10 each animation cycle, right? So pretty simple, but it gives you an idea of how the different how the subclasses can. Oops, I keep doing this. I'm so used to Xojo. I keep hitting Command R in Keynote, and it just hides and shows the ruler. I'm trying to hit play and hit Command R for compile. So basically, just wanted to show you kind of a feel of how subclasses, you know, can work and inherit various things, and since they all inherit from the parent. So how many of you guys have used class interfaces? Anybody know what class interfaces are? Okay, got a few of them. Class interfaces are one of those things that's, once you've used them, you kind of never go back. They're just super cool. But if you haven't used them, they're kind of bewildering and confusing, and you can't figure out exactly how to use them or why you should use them. But basically, I like to look at class interfaces as a disguise. So have you ever had code like this? If you haven't done a lot of object info, you may have run into this where you've got two different kinds of objects. I'll show you an example here. Actually, I forgot to delete that slide. Okay. Basically, you've got let's say you've got a method and you're passing something into it, some kind of object into it, right? So that you might try it the first way where you just say, you know, take any object, right? Well, that can be too broad because you can basically pass any object into that, and that's not good. Then you can go too limited. You can say, you know, pass item as enemy ship class. Well, now only enemy ship classes can be passed there. You can't pass another kind of ship or another kind of object. If you got a game, you might have different types of game pieces. Well, you can only pass, enemy ships here. So a better way to do this is to use a class interface. So a class interface is like I said, it's kind of like a disguise. We're basically going to trick the IDE or the compiler into thinking that this object and this object are really the same, even though normally you'd have to write two separate methods for this object and for this object because you can't pass them both into the same method because they're different. So what we do with a class interface is we define a template and we say, you are both, sprite type, and then you could basically go through your project, and anywhere you have something that is displayable, you can say you're a sprite type, you're a sprite type, you're a sprite type, and then basically you could pass all that to this routine, and it would know how to talk to a sprite type and display it. So the way that this works, I'll show you a little demo. This is a program that I wrote. So what we're doing here, this is a program that's gonna display some text, but we don't want our main program knowing it doesn't know how the text is going to be displayed, right? It just knows I've got some text, I'm going to display it. And so what I created is, in this little demo, the actual control that's going to display it can be selected by the user. My screen switched to really high resolution, so I have to squint to see what the file names are. So basically, the user can just pick here. I want it displayed in a text area. I want it in a dialog box, whatever. Okay. So, oh yeah, that's a good idea. Sorry about that. I'll zoom in here. So, yeah, I'm not used to such a high-res screen. So, okay. So let's say we picked a list box. So if I click the display button, the text is going to display one line by line in the list box. Okay. If I do text area, it's going to display in the text area. If I do a dialog box and hit display, it's going to give me a dialog box. You can see that. Wonderful fake Latin text. And if we do clipboard you can't actually see since it's invisible, so I add a little show clipboard button here, which displays it in a dialog box, but it's displaying the clipboard, so you get a feel for what's going on. So let's take a quick look at this code, and I'll zoom in here so you can see. Basically, I've created several different subclasses for the different things. So I've got a custom list box, a custom text area, display message box. I've got several different classes here. So what happens is when you click on the push button that says display, it actually looks to see which radio button has been selected by the user. It assigns that to the variable aDisplay, which is of type display interface. Now this is where it gets interesting, because this is of type display interface. It's not a class. This is our display interface. Okay, so all the display interface does is, if I can find it here in my code, it's just a definition. There's no actual code in an interface. All it is, it's just saying, it's like a template. It's just basically saying anything that's display interface has to have a display method, right? So we assign this by selecting an object, like in this case, I don't know how I did that. Okay, so we select something like, for example, custom list box. What's going on? Okay, so we select custom list box. We go over here to the inspector. This is a text area. Oh, I'm doing text area, not list box. Okay. And inside this dialog box that comes up, we can see that display interface has been checked. That tells us that this is a display interface type object. And so that's how we can use this code and actually say that the text area right here is assigned to a display, right? Because normally that would not work. That code would not work because it's a different class, right? And you can't assign class A to class B. That doesn't work. But in this case, they're both of type display interface, so it allows the assignment there. And then the main code, the only real code we're doing, is this one right here, which just says, goes to that object, which is of display interface, and says, display the text. So our main code right here, it knows nothing about individual objects. It doesn't even know which object is which. It doesn't know what we're talking to. It doesn't care how that's being displayed. It's just saying, you display it however you want. So the beauty here is you could customize this later and add other types of things. So a perfect example is, let's say you had a program and you had a way for the user to display some data. And then the user says, well, hey, I need to print. And you go, okay, I'll add a print object. And now that same display of data, instead of displaying it to the screen, you send it to the print object. The print object says, okay, I'm going to print it. And it knows how to print it. And your main code doesn't have to change, right? Because it's just saying, display it. And then the user says, well, I need a PDF. Well, now you can just add a PDF object. Now, the code for actually creating the PDF has to be in that object, obviously. But the big thing is, the big advantage is your main program doesn't have to change, right? It's just talking to the object and saying, display yourself. And in this case, it's actually displaying a PDF, right? It's converting it to a PDF and letting the user do that. So you could add all kinds of conversions, things like that, without having to modify your main code.
So anything you want to address within a display has to be defined in that interface.
So the question is, anything that you want to address in a display has to be defined in display interface, correct? Yeah, so that's correct. So basically the interface that I've set up, the only command that it has, the only method it's saying you have to have a display method. That's the only thing. So that's the only thing that the objects have in common, and that's the only thing we can address between them. So if the object actually, like for example, a list box has like an add row command, whereas edit or text field does not, right? Or text area. We can't use that command on that thing because it doesn't know about that, right? We can only use the display method because that's been defined as part of the interface. So the interface is limiting you to just, again, it's like a disguise. We're just saying, okay, these things are in common between these objects, and then the compiler doesn't care that they're different kinds of objects. It's just going to you'll be able to talk to those objects with these specific, and you can create as many as you want. And you can't have properties or anything like that in an interface. You can only have methods because that's all you're defining is how to talk to this object. You're saying this object communicates in this. You know, you could think of it like languages, right? You know, this one speaks French, and so you can talk to it in French. This one speaks German, and you could. That's kind of what you're doing. You're just saying these have these things in common, and these are the methods you can use. Does that make sense? Got a question?
Can you show us the methods of listbox there?
Sure. He wants to see the methods of listbox. So we'll go into listbox. Yeah, so listbox basically it's taking the text and splitting it and doing add rows. Whereas, for example, the custom text area, it's basically just doing a text assignment, right? Because it doesn't need to do anything like that.
And it's also the display method is it like added, by default now, thanks to you said it's an interface, or do I have to add it myself?
You'd have to, the display method, you basically, once you select your object, if you want to assign an interface to it, you go over to the inspector and choose your interface and just make sure that it's checked there. And it won't do it automatically. If you create a new object, you have to assign that and tell it it's this type of interface. And if your object, it will actually add that. If your object doesn't have, like in this case, we have a display method. If your object doesn't have a display method and you say it's a display method thing, it will insert that method for you. It won't have any code, but it'll put the shell of the method there. So if your interface has 10 methods, for example, you create a new object, you say you're this type of interface, boom, you get 10 methods. Then you just have to put the code in for that specific method. So, and again, all these code examples are available for download, so you can play with it at your heart's content. Yes, another question?
Is it possible to put code inside the interface method?
Is it possible to put code inside the interface method? No, because the interface method is just a template. It's just you're just telling the compiler these two things are both supporting this same language, right? They're both talking have this verb, this method, and that's all you're doing is just telling it what it is. There's no actual code there. So, all right, let's get back to some more stuff. So this is basically that same source code we just looked at. That again, the heart of it is just talking to an object and saying display yourself, and then the object displays itself. So what are the benefits of OOP? So we've talked a little bit about the biggest one, of course, is it's going to save time. Hopefully, going to save money because it's kind of the same thing. It's going to save a lot of headaches. Hopefully, the main ways that it does this is with reusable code, right? Because the idea of objects is they're kind of like think of them like Lego bricks, right? You can just take an object from here and put it here and plug them together and everything works, right? Reality isn't quite like that, but that's kind of the ideal, okay? So the actual example I'll show you in a few minutes about the drawing program that I created, I actually created that as part of my word processor. I wanted to have a way the user could like annotate graphics and stuff, like bring in a picture and write some notes on it and stuff. And so I created basically a class. It's technically it's a window that's an object that has a full drawing program inside. It's actually a container control, and it has a full drawing program inside of it, right? And so I took that subset out, and that's basically the demo that I'll show you in a minute that you can look at. And so, which actually brings me to a little tip that I do. When I did that, the first time I was doing that, I started writing it. I was running it inside my word processor, which is like, I don't know, 50,000 lines of code or something. So every time I hit run to test the drawing program, it has to compile the whole word processor and all that extra code. And it took a lot of time. So what I did is I took that module out, put it in its own project by itself with nothing else, and just started writing that module independently. And the advantage of this is faster compiling, easier debugging, it's less distracting. I don't have all that other code that has nothing to do with my thing. And the big one is it helps ensure it's really independent, because I'm writing the object all by itself. All I'm trying to do is get have it edit the drawing and let you do stuff with the drawing. I don't need to know about the word processor and everything else about how that's going to work, right? So this ensures that it's completely independent. I've done other things where you create the object inside the main program, and then you accidentally tie it to other code in the program, then you try to reuse that object later, and it says, oh, I can't find this, I need this method or this routine or this variable or something, and you go, oh, it's not a self-contained object, which is that's the goal we want, is to have everything as generic as possible so that you can reuse it in multiple projects, and that's often very hard to do, but this is a good tip. It just speeds things up, is just, create the thing completely in its own project by itself. So we'll take a look at, this is the demo I've been talking about. This is my little drawing program. So I created this. This is a container control, basically, that's in my word processor. And you tell it I want to edit a drawing, and this comes up, and you can basically, it's different than this, but I created a subset of it for this demo. But basically, we have a bunch of drawing tools. Now, when I first did this, I did this presentation in 2014, I think. And what I did then was it came out as a little bit of a gimmick, but I tried to let the audience vote on which tool we were going to add. And then I would actually add that tool live during the presentation, and it creates a lot of stress, and you get to sit and watch me type and code, and that's not a lot of fun. So I decided to not worry about that. But what I'll do is I'll show you. So in the when you download the demo projects, I've got two of them. So one is called Simple Draw Raw, which is it doesn't have these extra controls. So the three controls that we're gonna add is called picture, text, and round box. So if we click on those, nothing happens. We click on the boxes, and the other objects, they show up, and we can move them around and move them, change the opacity, and do things like that. That works, okay? But there's no text and picture objects because we haven't added those. So let me quit that for a second. And so then we also have one here called Simple Draw Complete. And this one I've added everything in. So what I've done is, just to make things so you can still kind of see how to do this, I've created some movie files. And for example, I'll just bring up this picture one. So there's no dialogue there. It's just a little movie that will actually show you me. I'm doing this step by step, adding a new class and adding a picture object to the Simple Draw drawing program. And so you can actually watch these. They're only, I don't know, this one's what does it say? I can't tell if it doesn't show me the full time, but it's probably only 5 minutes long. So I mean, they're just a few minutes for each one to show how to do it. But basically, you can download these and watch them on your own and see how easy it is to just add a whole brand new object. And when you add the brand new object, you can then open and save files with those objects in it, and it just works. It's just amazing, and you can't believe how easy it is to go. You think you have a drawing program, you're thinking, I want to add a new, like a text object, and you go, that's going to be complicated. And it turns out it's really simple, because basically 80% of the work is done in the default objects, and all you have to do is just add a few little tiny details. And so there's several different. I also have ones for these other demos that you can watch too, just that I included. But so let me show you real quick. Let's see. Let me go back to the raw one, and I'll show you. Well, actually, no, wait. I'll run this twice, and this will be really confusing. Actually, it's not going to do it. Okay, what am I thinking? Okay, I'll run the complete one first, just to show you how this works. So what I'm going to do is I'm going to open a file. These files are XML. So I'm going to pick drawing number 2. And we can see here, I'll zoom in a little bit if you want, if that helps a little bit. Got a picture of my cats, and I've added some text, made it change the color and the background and size and a few different things, right? So get a good feel, remember what that looks like, okay? Because what I'm going to do now is I'm going to go to Simple Draw Raw. We're going to open the same file. Now what's going to happen when we open a file, this program here doesn't know anything about pictures, right, or text, because we haven't added that in this version, right? It still opens the file just fine. It just doesn't display those objects because it doesn't know what they are, right? So it's basically the file is just a list of objects that have been placed on the drawing. And so it's stepping through those objects and it says, I don't know what a picture object is, skip it. Doesn't do anything, right? Unless if I save this file now on top of the old one, obviously it would save only this information. We'd lose those other pictures. But this to me was a really cool feature when I discovered this. I was like, this is so cool because it doesn't even, I thought maybe it's going to crash or something because it doesn't know how to do that, but it works great. So let me show you, I'm going to close the raw one just so I don't get too confused here. So let me zoom in here. We'll take a quick look at some of these objects. So for example, these are all the different objects. So each of these is a different drawing element that we can draw with, right? So we draw with lines, we can draw with rectangles, text, different things like that. So this is the text class one. And for example, this node right here, this method right here called set from XML, this is the command that actually reads the XML and translates it into whatever this object is going to do with it. So basically our main program is just telling the object, you know, read yourself. Here's some XML that's supposed to be an object of your type, you know, read it. I don't know how to read it, you read it. So the object knows how to read itself. And basically the only thing it's really doing is just finding the text node and reading whatever the text is and storing that inside of itself. And that's the text you see when you have that object there. Other aspects of other properties of the object, like the color, the size, and other things, are part of the default drawing object. So if we look at, say, let's see, I think it's probably, well, actually we can do this. Let's see. So if I click on the actual object itself, we can see its parent is object rect class. So if we click on that, we will see that it's got the same methods, including set from XML. Now it's a little bit more complicated. It's looking for the rect command in the XML. It's looking for the fill color, the fill transparency, a few different values. Well, those things are the same basically for all the objects. They all have transparency and a size and a shape and things like that. So this stuff all happens, and then basically when it finishes this, it then calls the subbed object, which is our text object, and it adds the actual text, right? So when you're adding this, the only thing we have to add is this code right here. This is not much code, a few lines of code, and that's all we have to add. We also do the reverse of this, the get as XML, which basically returns, it creates an XML version of whatever data that object needs. So in this case, it's going to create a text node with whatever the text is in it. Okay? Any questions about that? Pretty cool. And again, you can watch the movies, and you'll see me actually adding all this and all this code. There's a lot of code here, so it's way too much for me to just explain in a short session like this. But the code is pretty cool. You can really see how easy it is to just say, I want a new type of drawing object. I want say you want a triangle, right? There's no triangle thing. You could say, I want a triangle type object. You could create that.
And that's going to be in the XDC deck.
Yeah, it'll be in all the stuff that downloads from the slides, and also I'll have a URL at the end of the presentation that I can give you, and you can use that, download it direct from me if that's easier. So, all right. So one of the biggest things that you want to do, one of your goals with object-oriented programming is to decouple your code. Okay, when you have coupled code, that's where this code and this code are basically connected in some way. And this happens when you just refer to stuff. Have any of you heard it like you're not supposed to use global variables? Right? I grew up where everything was global variables, and I used lots, and then it's like, no, you're not supposed to use global. Do you know why you're not supposed to use global variables? I always tried to figure out, I was like, what's wrong with global variables? Well, the problem is, when you use global variables, everything that touches the global variable is creating a link between that thing and the global variable. So if you then change something down the road, like change the name of the global variable or something like that, you've got like 20 points in your code that just all broke, right? Because they're all talking to the global variable. And so the more you do that, the more problems it creates. That's how you get what we call spaghetti code, So we've got a dialog here. So this item, the more things it touches and interacts with, the more coupling you have. And the ideal is to have as little coupling as possible so that when you change code, the biggest benefit of object-oriented programming is when you have to go change stuff, right? If you write code and you never have to make changes to it, you don't need object-oriented programming. You can do whatever you want because it's going to be fine. The problem is when you have regular code and you try to go in and you make changes, then you run into problems. So object-oriented programming helps you with that because it minimizes all the spaghetti code that we're used to seeing when we have all different types of things talking to each other and getting all coupled, and then as soon as you make a change in one spot, half your program breaks. Got a question?
The trade-off, though, is you're adding a lot more complication.
He says here, a trade-off is you're adding a lot more complication. I would say you're adding some complication, not necessarily a lot. It depends. But there are also other benefits that you get when you, in terms of clarity and other things that are also beneficial to that. So when you get a lot of complicated code like this, you can't really keep it all in your head. It's hard to keep all. When you have a nice object-oriented model, it's easier to, okay, this connects to this, and this is how this works, and this is the structure. Your brain understands it better. And even though it's technically a little bit more complicated to set up, I think the benefits outweigh that. Exactly. That's my point. You're investing in the future. Exactly. Because again, if it's something you're never going to edit again, if it's just a one-off project, you're just going to do it and never run that program again or never need to edit it, it's probably not worth the effort to go to extremes to make it object-oriented programming, object-oriented. But if you are planning on editing it, then it's going to help a lot. So like I just mentioned, clarity is one of the biggest benefits of object-oriented programming because you understand it better. So let me show you some examples of that. Which of these lines of code is easier to understand? Okay? They basically do the exact same thing. The first one, you kind of, even if you don't know what we're doing, we're assuming it's some kind of accounting program. We have a withdraw method, and it looks like we've got an array, and we're passing a savings account type, and then we're apparently withdrawing $250 today, right? We can understand that, right? But look at the second one. We have an object that's an account. We're looking at the subcategory of that called savings. We're calling the withdrawal command today 250. That's just, I see this and I have to think. I look at this and I go, I know what that does, right? I don't even think about it. I can see that. So this is an example, very simple example, but of just how much clearer, object, and this isn't really complicated, but even that you can go, that's a lot easier to do. So that's one of the key benefits. Here's another example is I use a text format called Markdown. It's just plain text, and it has a converter where you can convert it real easy to HTML and XML and other kinds of things. So I wrote code in Xojo to convert, so I created my own converter. So I just started off real simple, just a convert command, convert Markdown to HTML. It returns, pass it some text, it comes back with HTML. Well, that was pretty simple. Then I started like, okay, this is working. Now I want to add some features. So I added a feature called Smarty Pants, which is a flag that basically tells it to smart quotes. It takes all the straight quotes and turns them into smart, and double hyphens turn into dashes, and just kind of makes the punctuation look nicer. And then I started coming up with other things. I wanted to add some CSS to the HTML. So rather than have the thing come back and I have to manually insert some CSS, I could say, just pass the CSS to the command, right? So after I started adding a few of these different things, I started getting all kinds of weird convolutions of my methods here. Got really complicated. And then you have to start thinking, okay, which one am I calling? Which is the order? And what, it just gets really convoluted. So then I said, okay, forget all this. I'm going to do a class, okay? So I do a Markdown class, and it has one command, convert. That's it, right? And then I can set all the different parameters, the settings that I want it to, how I want it to convert. I can just set it as various properties of that class, right? Of that object. So I just set those settings and then call it, and it's done, right? So a lot simpler and a lot easier to do. And if I want to expand this and add a whole bunch more options, I can without making it a lot more complicated. It's going to still work the same way. It's still going to have one command, convert. So what happens when object-oriented programming gets complicated, right? You guys have mentioned this a couple times. It takes more time to, set up. You have to do a little thinking in advance and plan ahead. One of the biggest things I find is that thinking generically is rather difficult, because you're focused on, I'm writing this project, I'm trying to solve this problem, and you're thinking, okay, I'm doing that. And it's hard to go, okay, wait a second, if I write this in a more object-oriented way, I can reuse this object in this other program, which is completely different. And you think these two programs don't have anything in common, but sometimes the basic object structure can be very similar. And so if you write this part generically, you can reuse it over here, and it saves you a lot of time in able to use that object-oriented structure in another program. And you also want to be a little careful of mixing OOP and non-OOP techniques in the same program, because that can cause some trouble. So I'm going to show you an example here. We're going to go back to the invaders game, and let's say we wanted to make the red enemy smarter. Okay, so the simplest way to do it, to make the red enemy smarter, is we just want him to basically move towards the player's ship. Right, he's going to attack the player's ship. If he actually had collision detection, we could have him, crash into it and kamikaze blow it up. But how do we do that? How do we make him go towards that ship, right? He's going to have to know where the ship is. So where does he get that information? If we actually look at the code, this is the structure of the original Invaders game, right? So everything's on a window called Window 1, brilliant name, and all the ships and property are just properties of that window, right? So the logical way to do it, the non-OOP way, the default way to do it, is to say, oh well, I'll just talk to Window 1 and ask it where main ship is, and find out the horizontal location, which is X, and assign that to a variable, and now I know where that main ship is, and I can head towards it. Well, that'll work, but it's a non-OOP way of doing it, because we're basically kind of cheating. We know what Window 1 is where the ship is, so we're just using our godlike knowledge to say, okay, I know where the ship is, let's just talk to it directly. Well, what happens if somebody comes along and says, Window 1 is a pretty stupid name for a game window. Let's call it Game Window, right? So we rename it Game Window. Well, this line of code now breaks. It doesn't work anymore. Now we've got a bug, right? It won't compile. And obviously, if you just do that in one spot, not a huge bug to fix. But if you've done that 50 times throughout your program, that's kind of annoying. So a better way to do this is to do it in an OOP fashion. So this is where we actually make a game class, and we make the whole game is inside of game class. So game class itself might be on a window, but we don't care what the name of that window is or which window is. We don't need to know any of that. We just need to know that everything is inside game class, which makes a lot more sense because it's a game, everything's inside it, right? And then all these ships are inside there, and we can create methods and have a system in there for it to report exactly where that main ship location is. So I have a class here called main ship location. It can just talk to that. So if I decided to, like right now, for example, the ship only moves horizontally. What if I decided to make the ship allow you to move the ship vertically, right? Or do some other things with that. This, if you did it the old way, you'd have to do a lot of rewriting. With this method, because it's all part of the game, it'd be much easier to rewrite that and add that support for that, because you've got a special function, main ship location, that's going to report that. So anything that needs main ship location is not talking directly to the main ship to find that out. It's calling this method and getting it from there. So so let's take a quick little.
Wouldn't you just put the main ship in a property and then you would know?
But you still have to know. He's saying, couldn't you put the main ship in a property? But the problem is, you still have to know where that property is. So you're still using your godlike knowledge to know that the property is there.
The game.
Oh, inside the game, yeah. But that's kind of what we did. I'm just using a method for that. So I'll just show you real quick. We're getting a little slow on time, but if I run the game Invaders 2, you can see the red ships will follow. See, they start heading, they follow my ship. So when they come off the top, they're going to come right over here. So we'll wait until they get a little closer, and then we'll swip and see I swip to the other side, and they're coming over for after me. So it works. They're smarter. All right. So if you guys want to have some more information about some of this stuff, you can explore design pattern. There's a couple design pattern books. I like the head first one, is a little bit easier to get into. There's also a book on refactoring, a little bit technical, but it's refactoring is basically taking your existing code and making it more object-oriented, making it better. And so some of these books give you a lot of tips and ideas that if you're not familiar with design patterns, it's big topic. But basically, I think of design, I don't really like the term design patterns, but they're basically just techniques, and they're named techniques. And the nice thing about design patterns is since they have names, we can all come together and say, well, I'm using this pattern, and and we know what we're talking about because we can name them versus just saying, well, I do it this way and trying to describe how you do it. So don't be too intimidated by the term design patterns, and so that sounds complicated, but it's just a technique. It's just different techniques for dealing with objects. So, any questions about that? So again, you can purchase subscriptions to the magazine and get back issues and printed. We do the printed books, which is each book is a whole year's worth of issues in one printed book. Got a few left out there. They're all 50% off during the conference and a few days afterwards, probably till like the 4th or 5th or so of May. So you can still go online and order if you're interested. And there's a lot of, we don't do, it's not nonstop object-oriented stuff, but we do have our written articles, and we have other articles about object-oriented programming if you want to read more about that. So, and I think that's it. So here's the URLs. This is just a direct download from my website. If you want to download it there, it should also be available. I gave the stuff to Dana, so it should be available there. But if you want to grab it, that's easier, you can. So, got questions? Okay, go ahead.
In Java, there's a method called parent something.
Okay.
So how come Xojo doesn't really have that?
Okay, he's talking about in Java, there's a method called parent.
Yeah, it relates to your parent class.
Right. In Xojo, there's a super, which is basically the same thing. So if you do .super, that's going to tell you what the parent class is. So that would basically be the same thing. And there is also, like in Windows, you have parent, and I think it's a class. When you have a control, you can do the parent. It'll tell you the name of the window that the class is on.
So if you're
Yeah.
passing in from a parameter like a child class, then you do .super to get the parent.
Yes, he's saying if you pass in a child class, you can do .super to get the parent. So yeah. Well, actually that's a good question, because that's going to tell you the class type. It's not going to tell you the actual object. I have to think about that, because you could write your own thing there. You got a comment, or I thought somebody. Yeah, you could write your own. Put that information in there if you wanted to. You could write, just add a properties that would store that information if you needed that.
So you would store
So.
the parent inside a child.
Right. Basically, it's kind of like a linked list. You can say, my child is this, and then the child could have my parent is that. So when the parent creates the child, it could point to you could basically assign that object to that property, and that would let you do that. But yeah, because the super is just going to tell you what the class is. It's not going to tell you the actual object. So that's the key difference right there. So, somebody else had a question? Oh, Jared?
Yeah, so in your game class example, do you actually have to instantiate that somewhere?
You do.
Do you have it
That's a very good point. Yeah, he's saying you have to instantiate.
my question is, would that instance of game class be on your window? Would it be window 1?
Okay. So he's referring to me instantiating game class, and that's actually I left it out because it's just a little bit complicated. But I'm actually using a design pattern that I learned at one of these conferences called singleton, which is there's a design pattern called factory design pattern, which basically it just creates objects. So it's basically like a method, and you say I need a new type of this object, right? Like, so let's say it's a game, and you say I need a new ship. So you'd say give me a ship, and it returns a ship class all filled out, however it's colored or whatever. Okay, I'd probably actually do that in the game code. I can't remember, but so it creates a ship for you, right? And you've got all that stuff. There's a variation of that called singleton, which normally when you ask for a new object, you do a new object. You always get a brand new object. So if you tried to talk to, each time you tried to talk to game class, you would get a whole nother game. So you'd have game class 1, and you're here, and then you get a second one, and you get a third one each time you talk to it, which that defeats the purpose of what we're trying to do to see where that ship is, right? So what you would do as a singleton is the singleton factory always only returns 1, right? So it says, is there already a game class in existence? Return that one. Don't create a new one. If there's no one that already exists, create a new one. So there's never be more than one. And then that allows you to, whenever you refer to those sub-objects in that game class, there's only one.
So then your methods are shared methods then, so you can just call the class dot that.
It's not really shared methods, but there's only one of that object. So when you talk to it, you're only getting the one. There's only one ship in existence, one player ship. So you wouldn't have any conflict of having more than one. So there's probably other ways you could do that, but that to me was the simplest way to use that. And it's a real simple design pattern, and I liked it, and I said, oh, that's a cool idea, so I'll just do that, and that works really well. So, any more questions?
And is the singleton class saved in the window?
No, singleton isn't a class. It's just a design. It's a design pattern. So it's just a technique. So I just have a method that's returning that particular. It's just returning, that object. So if we actually look here at yeah. Oh, I thought somebody was saying something, but let's see if I can actually find. Okay, so here's what the game class is. So it's got all of our stuff. Oh, I do have some shared methods in there. So okay, it is a shared method. Okay, there it is. So if mGame is nil, meaning there's no game in existence, then you return a new game class. If mGame is not nil, it just returns mGame, right? So this is basically the singleton method right here, right? So it basically is going to always return the only one that exists. So mGame is a shared property right here, along with the ships and everything else that's in there. Does that make sense? And it's private, so it's not something that things can actually, other things can access. It's this method is the only thing that can access that, and everything else just talks to game class. The instance of game class. So, that make sense? Everybody get that? Any more questions? All right, last chance. Okay. All right, thanks.